Hello and welcome to the C programming lecture on char arrays, also known as strings. So what is a character array? A character array in C is an array of characters. This can also be considered a string. So in other words, a string is a 1D, a one-dimensional array of characters. Typically at the end of a string or an array of characters, it should contain something called a null character, which is noted here. The C standard library actually comes with a header that has a bunch of different functions for handling these char arrays or strings, and that is going to be the string.h header. So here's an example of a char array, and we've kind of seen that in the last lecture on just regular arrays that we've shown. But here's a convenient syntax for us because we're using character arrays. So here we have the type with the array syntax, but instead of having some curly braces, we can actually just set it to some constant string, some constant string being just a regular old string value baked into our program, like here, right? Static, actually on line 6. So we have the value test with our null character. So the printf function actually provides a formatter, which is the %s sign that will loop through each of the elements inside of this string, and it will, whenever it hits the actual null character, it will stop printing that out and then continue on with this formatting chain. So you can see here that it prints out the test value of our particular string, and what we can actually do here is we can use a strLength function that is defined in the string.h header and actually loop through each of the individual elements and index them and print them out just like we did here. So you can see that the string length is +1 actually will go through each individual element of with a character, but adding one to it actually includes this null character here. So again, this is a very brief lecture on the differences between basically a different type array and a char array. Char arrays are typically treated kind of special because they sometimes represent strings. So the strings are just one-dimensional arrays that should be terminated with an extra character that is the null character. So however long your string is, you want to add that null character at the end because it's important for most processing to know when that character needs to end. And these sometimes are referred to in other languages as C strings. So the strLength function is part of the string.h header, and it will return the length of the string, not including the null character. So if you want to include the null character in that length, you need to add one to that, whatever the output is of strling. So I want you to, before you move on to the next lecture, just create a program that contains an array of strings. I want you to display each string to the terminal. So you have an array of characters, and just print out each one and see what happens. Okay, let's go ahead and just mess around with some C strings inside of our environment here. So again, first things first, we're going to go ahead and make a file, open up that file, and we can go ahead and write our hello world program like we normally do. And I just want you guys to build this particular habit just to get used to being able to understand some of the syntax. And especially as a beginner, I just find this to be particularly useful for just when you're getting started in general. So we want this. Okay, everything's compiling, everything's working great. We can get rid of that and not worry about that anymore. So the first thing we're going to do here is we are actually going to make a char array of arrays. So just like our exercise, what we can do is something along the lines of, let's say that we have 2 rows. Let's say that our buffer for each string is, I don't know, 10 characters, something like that. And let's think here, we'll add this. And each string, let's just make each individual string. We'll say testing, so that's 1, 2, 3, 7, 8, 9, 10. Right, so let's just do this. Right, so, and we'll double check the size here. The extra comma at the end doesn't matter. It won't bother the compiler. So we have 4 letters, and then another 3, so 7, and then 8, and then 9, and then our 10 is here. So yeah, that's exactly what we need. So now what we can do is let's just print out. We can use a for loop if we wanted. You don't necessarily need to use a for loop since we know each index, but let's just do it for good practice. We know the size. We're not going to worry about any length stuff right now. We'll just do this, keep it nice and simple. So %s again is a string, and because we have our null terminated character here, it should terminate at that particular line. So let's go ahead and just pass in that particular element here. So it will be this row and this one. So we should see testing 1 and testing 2 in our output. That's exactly what we see. So again, this syntax is a multi-dimensional array. So what's actually happening here is that within each of these particular rows, we are actually in each individual element inside of here, it's actually like this. You know, if we were to do character by character, it would be something, it would be much more tedious to just sit here and type this out, you know, one by one. So this line on line 14 is essentially, you know, this is the, here is the longer version of this. I can show you a shorter example, but this, you know, if we had a smaller buffer here, we wouldn't have to worry about it as much. So what do you think would happen if I remove this and just added like another one inside of here like that? So we have our entire actual buffer here, our little the array, the second element, or this column, you know, is filled completely without any actual null character. So when we print this out, it doesn't know that it needs to stop here. So just kind of think about that real quick, and let's just see the output of this program. So I recompiled it, printed it out. Now you can see the first time it prints out, it actually prints out both lines. And that's because when we pass this this variable, our first actual row, into this printf function with this %s, it's actually looking for, like I said inside the lecture, this null character, and the null character doesn't exist here. So for instance, if I deleted this and put the null character, let's say at, let's put it after the t, what do you think would happen? Let's see. Yeah, so this should not be surprising, because this is basically the terminator of the string. This tells most string processing functions inside the C standard library to terminate the string. And most standards in general, most programs that you use that manipulate strings will have this standard as well. It needs to know when to stop reading a string. So, you know, I can place this character anywhere inside of the string, and it should just terminate it at that particular point. So now we should just see test, and that's exactly what we see. So again, this is pretty important. Now that doesn't mean that those other elements don't exist inside of memory with those particular values. They definitely do. What it means is when you call a function and pass in this value, it's searching for this variable to basically do a early out, like a break statement, like we've already covered. So imagine writing our own print string function, and we output it to the console. We would, when we're looping through, we know our terminating character is this, and when we hit it, we can break out of the loop. So anyways, I hope this was pretty insightful. The longhand form of this, again, is just actually going through, and just like our other example with elements, is we just assign each individual character. This is the shorthand syntax. This is fairly convenient to do this rather than the earlier example.